In section 3.3, we're going to work with graphing using the intercepts. Previously, we've learned how to graph using an input-output table. And the key vocabulary we're going to need for this section is what is an x-intercept and what is a y-intercept. So let's talk about that really quick. So the x-intercept is the x-coordinate of a point where the graph crosses the x-axis. So right here you can see that my x-intercept is at x is equal to 3. So 3, 0 is the ordered pair. And the y-intercept would be where x is equal to 0, because when x is equal to 0, we're on the y-axis. So this is the point where we cross the y-axis. It's at 0, 6. So you might say that the y-intercept is 6 and the x-intercept is 3. Okay, so if I want to find the intercepts, if I want to find the y-intercept, I set x to be equal to 0, because that's what x always is when I hit the x-axis. And if I want to find the x-intercept, I set y to be equal to 0, because whenever my graph hits the x-axis, y is always equal to 0. Okay, so let's take a look at this. If I want to find the intercepts of this graph, let's say I want to find the y-intercept, so I set x to be equal to 0. And I'll get y is equal to negative 12. And that is my y-intercept. If I want to find my x-intercept, I set y to be equal to 0. I'm going to add 12 to either side. And then I'll multiply either side by the reciprocal of 3/5. So that'll be 5/3. Now, I know when I multiply something by its reciprocal, it's going to just equal 1x. And if we look at multiplying a fraction times an integer, we can always assume that the integer has a numerator that is the integer and a denominator of 1. So I know that 12 is 3 times 4. I know I can cancel the 3 with the 3. And I'll multiply 5 times 4 is 20 over 1. That's 20. So my intercept here is x is equal to 20. Okay, if we wanted to use those intercepts to graph an equation, let's do this one more time. Y is equal to 1/2 times 0 plus 1/4. So y will be equal to 1/4. And then if I find my x-intercept, 0 is equal to 1/2 times x plus 1/4. I'll subtract 1/4 from either side. And then multiply by the reciprocal of 1/2, which is 2. And 2 times negative 1/4 is negative 1/2. So if I wanted to go ahead and graph this equation, let me go ahead and put in axes for this. And I know that my y-intercept is at 1/4. So let's do 1/4-inch scale. 1, 2, 3, 4. So that's 1, 1, 2, 3, 4. That's 2. If that's what I did vertically, I'm going to try to do the same horizontally. So when we look at the y-intercept, it's at 1/4. That's right here. And my x-intercept is at negative 1/2. So that's 1/4, 2/4. That's negative 1/2. And this is my equation, or my graph, based on the intercepts. Okay, so once I have 2 points, if I draw a line between the 2 points that connects the 2 points, I will have graphed a linear equation. It always takes 2 points to determine a line. Okay, if I want to just look on a graph and find the intercepts, I can see that y is equal to 1, 2, 3, right? Y is equal to 3 is the y-intercept. And negative 1, negative 2, negative 3, negative 4. X is equal to negative 4 is the x-intercept. Now they haven't asked me to take this information and do more with it, but I could go ahead and write the equation of this particular linear equation by knowing this information. Okay, so when we want to go ahead and relate intercepts, points, and graphs, remember if we have, right, x-intercept being A, that means that the graph crosses the x-axis as A0. And if the y-intercept is B, it means that the graph crosses the y-axis at 0B. Always remember that if I have the y-intercept, x is 0. If I have the x-intercept, y is 0. Every time. Okay, so let's look at working with a problem. I'm helping to plan an awards banquet for school, and I need to rent enough tables to seat 180 people. There are two different sizes of tables. They have small tables that seat 4 and large tables that seat 6. And I can model my situation here that any combination of small tables and large tables that will equal 180 is a possible solution for me. X is the number of small tables and Y is the number of large tables. So first I want to find the intercepts, and then I want to graph the equation, and then I would like to determine different possible numbers that I might go ahead and rent, different numbers of tables that I might go ahead and rent. So let's start off by finding the y-intercept. 4 times 0 plus 6 times y is equal to 180. 4 times 0 is, of course, 0. So y would be equal to 180 divided by 6. So y would be equal to 30. So if I just get 30 big tables, that's one solution. Equally, if I want to find the x-intercept, I set y to be equal to 0, 180. So x will be equal to 180 divided by 4. Well, 180 divided by 2 is 90. 9 divided by 2 is 45. So x would be equal to 45. Okay, if I want to double check my work, 6 times 30 should equal 180. Yes, it does. 4 times 45 should equal 180. Yes, it does. So I've definitely done the work right. So I can rent 30 large tables and no small tables, 45 small tables and no large tables, and that's 2 of the 4 possibilities for the table combinations that I could use. So if we go ahead now and graph, remember we had x is equal to 45 and y is equal to 30. And if I want to graph the equation, I'm going to go ahead and put in my axes. I don't really need negative values, right? I can't rent a negative number of tables. That's just not possible. Okay, these are difficult numbers for me to do if I go by 1, so I'm going to go by 5s. So that's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. All right, now I've gone far enough now because I know my x-intercept is right here, 45. So I could do 0 large and 45 small. And now let's go ahead and do the same thing with our y-axis. So this is going to be 5, 10, 15, 20, 25, 30, 35. And I'm doing every other just to make it easy to write the numbers in. 40, 45. All right, and I've gone far enough now. I know that y is equal to 30. That's right here. Okay, so I could do 30 large and 0 small. Those are 2 different possibilities. And if I go ahead and graph my line now, these are all the different combinations that would, anything that's on this line is a certain combination of tables that would work in order to do this. So it's a little difficult for me to tell exactly off of my graph what are these really specific numbers. For instance, because I've done a scale of 5, it makes it a little difficult to say where exactly am I crossing the grid. It looks like I might be there, I might be there, I might be there. This is a case where you might want to go ahead and pull out a graphing tool. Okay, so here I've put my equation into Desmos, and you see that I can find any of these points by simply hovering over, and because I'm also have a little more detail than I had on my graph, it makes it a little easier for me to tell where I've got exact locations. For instance, right here looks good. 30 and 10 works as well. So I know I can do, 10 large and 30 small. And I could go ahead and pull up another location off of here. It looks like I can do 15 large and 20 small. And all of these are different combinations that would add up to those 180 seats. Okay, so we can pull the information off the graph. You'll notice limitations I had because I chose to do my scale by every 5. Then when I wanted to try to choose specific points that made whole number answers, right? I didn't want 0.33 of a table. There's no way for me to rent a third of a table. So it became a little difficult for me to pull the answers off the graph, whereas the graphing tool, Desmos, was very easy to use. As a final problem, let's take a look at this item with the submarines. So I have a submersible, which you might like a submarine. It's designed to explore the ocean floor at a level of 13,000 feet below sea level, so we're going to call that negative 13,000 feet. The submersible ascends to the surface at an average rate of 650 feet per minute. So the elevation in feet of the submersible at any given time, the elevation will be equal to 650 feet times the number of minutes minus the 13,000, which is the starting point. So we want to find the intercepts of the graph, and then we want to state what the intercepts represent. Graph the function, identify its domain and range. Okay, so if we want to find the intercepts, we had E is equal to 650t minus 13,000. So if I set t to be equal to 0, I'll find the elevation intercept. Right? The elevation intercept is negative 13,000. Okay, and then if I set E to be equal to 0, 0 is equal to 650t minus 1300. If I add 1300 to either side, equals 650t, and if I divide by 650t is equal to 2 minutes. Okay, I just went back really quick to double check, and I had made a mistake. It's 13,000. So then this becomes 20 minutes. Okay, so my mistake, I had dropped a 0. It wasn't 1,300, it was 13,000 when I transferred from screen to screen. Let's go ahead and put in our intercepts. Right? Basically, I'm working to get to the surface, so I mostly am going to be working below the x-axis. My y-intercept is the elevation, and my y-axis is the elevation, and my x-axis is the time. And my intercept on the y-axis is negative 13,000. So if we do 1, 2, 3, 4, 5, 6, 7, 8. Well, that's too many. I'll just have to go by 1. So 16. This is 2, 4, 6, 8, 10, 12, 14. So right here, all of these being negative, of course. Right here is negative 13,000. And then up here, 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 is my other intercept. Okay, so now if I go ahead and connect my dots here, and there's a reason I'm not doing a line that extends beyond. First off, the ocean floor was 13,000 feet below sea level. So negative 13,000 is the lowest I can go because I've hit the sea floor. And when I've come up to make elevation equal 0, I'm on the surface of the water and a submersible can't fly. So I can't go above the surface of the water using that item. I'd have to use like a crane or something else. Okay, so I've graphed the function. And then let's go back and look at the other questions they wanted. What do the intercepts represent and what's its domain and range? Okay, so what the intercepts represent is the y-intercept is the ocean floor and the x-intercept is how much time it takes to get to the surface. So it took 20 minutes to go from the floor to the surface. Okay, and you can see that we're starting here at time 0. It's our starting point. The y-intercept is our starting point. And our ending point out here is 20 minutes, but our ending elevation is at 0. Okay, if we start looking at the domain, you notice that my y values are all below 0. So y is greater than or equal to negative 13,000. But it's less than or equal to 0. That's the distance between the ocean surface and the ocean floor. And that is my range. My domain, I can't start in the past. So the time has to be greater than or equal to 0. And then less than or equal to 20 minutes. And domain is, of course, related to time, range, to elevation. And that's it for section 3.3.